And as you notice, when Rhino starts up, RhinoCAM plugin will automatically load. So you don't have to do any additional steps. It'll automatically load the CAM plugin. And any file that you can open in Rhino or import it into Rhino, you will be able to generate toolpaths within RhinoCAM. So RhinoCAM is a fully integrated plugin that works in Rhinoceros. So as far as the interface goes, you'll see RhinoCAM has a pull-down menu at the top just before help in Rhinoceros. And we have different modules. Mill is used from 2 to 5 axis applications for CNC milling, CNC routing. It's also used in laser applications, plasma, and then to a certain extent, you can also do it for like a water jet application as well. Turning is for programming CNC lathes or turning centers. Mill turn is currently in beta, which can do both milling and turning within the same like parts that require mill and turn. Mesh is a module that can be added on, which allows you to basically do mesh editing, mesh repairing, mesh healing, create mesh from point clouds, and also you can add supports. It could be used for milling, routing applications, also for 3D printing applications. Now the Nest and Art products are included with all our configurations of the mill module. So Nest allows you to do nesting of parts. You could do true shape as well as rectangular nesting. You can nest 2D. You can also nest solid parts like parts that are planar with flat panels. And Art can be used for converting raster images to vectors. You can also do relief operations with the Art module. So these are the different modules as you see here. And then by default, you can see the mill is checked and the mill browser interface shows up over here. We have 2 browser windows, the machining browser, which is over on the top half, and then the machining objects browser can either be docked below the machining browser or you can have it docked over on the side any way you like it. So the machining browser has 2 tabs, program and simulate, and the ribbon bar is just down below each of these tabs. You work your way left to right as you work through each of these groups in here. And the machining objects browser gives you access to defining tools. You can create tools of different types, starting with ball, flat, corner radius, tools for engraving, chamfer, taper, thread mill, face mill. You have lollipop cutters, dovetail tools. You can also do form tools and use them in operations like profiling or engraving. And of course, you have all the drilling tool types. You can set your tool number. You can specify your feed speeds. You can also compute and have the feeds and speeds loaded from a table as well. And you can have a library of tools automatically preloaded. So each time you start your application, it'll have those tools in there for you. Do you have any questions?
Is that the same library across, like, so I do in this particular project, I set up some tools that are the typical ones I use, and then I open a new file in Rhino. Is that a library you save to a file and then can open up in a?
Yeah, so we save it into a file called knowledge base, tool library files.
Oh, great.
So you can save it to a library, and then when you load a library, RhinoCAM remembers the last tool library you loaded, and it'll automatically reload the last tool library for you.
Great, thanks.
So you don't have to create tools for each and every part. So I have this file in here that you sent us. I'm just going to do a simple drag and drop into Rhino and then pick open. So you'll notice that the tools were automatically loaded in here that I had previously loaded from my library.
Great. So what I did on this, this has a bunch of things that kind of I do quite often. I roughed out the kind of surfacing with a 1-inch ball.
Okay.
And then I went in and started doing all the kind of 2.5D stuff. But you'll notice the recesses for each of those kind of recessed holes are at different depths. And I'm hoping, I could select them all and just, it would take the depth from the geometry. And then one of the other problems I had was in the other software I was using, drilling out those holes. They're slightly oversized from a 1/4-inch end mill. It would always go, it would peck and go back to a safe Z height, and it would just take forever to drill those holes. And I could not figure out a way to not have it come all the way up to safe Z every time.
Okay, so this looks like the through holes looks like they're about a 1/4-inch in diameter.
Yeah, they're just slightly, they might be exactly a 1/4 inch, yeah.
Okay, and then the The blind hole at the top here is the countersunk hole. Looks like it's about 0.6.
Yeah.
Okay, all right, we can certainly go with that. And one of the nice things you could actually do is when you do a roughing operation or something, if you don't want the cutter to like kind of dive into these holes, you can mask these holes in Rhino. You know, one of the things I like doing here is I just insert a new layer, and I can go ahead and basically cap these holes. I can either do like a patch in Rhino to patch them, or I can just extrude the surface, but the surface can be visible only when you do the, you know, roughing operation, so that the cutter, you know, when you do a roughing operation with a large tool, the cutter ignores these areas for you automatically.
Right.
So if you want to do it the way, you know, Rhino has a command called patch, and you can just select this edge in here, and if you press enter, it'll ask you the UV spans in here, you know, and then basically you can patch that hole right there, right?
And sorry, when you created that layer 1, did you create a duplicate copy of everything on the first layer?
No, I just added a new layer. I did not copy anything. All I'm doing is basically using the patch
That
command in
patch
here.
only is an additional element. You're not untrimming
Right.
that.
Yep, I'm not untrimming the hole. So I can do a patch, or let me show you. In this example, I'm just doing a patch. Now I can basically do the same for each of these holes, right? So you can see there's a, you know, the patch didn't work too well on this one here, right? As you notice it. The other option you could do is, instead of doing a patch, you could basically extrude. You could do surface extrude curve straight, and I can just pick these two edges in here, and I can just go right up to that point. That'll make it easier,
But
right?
that's not an extrusion because there's a taper to this.
Okay. So yeah, patch or something like that might work better for you.
Could I copy that geometry onto the other layer, untrim the holes, and just for the roughing operations go to the
Absolutely, we can do that. So I'm going to right click and say duplicate layer and objects.
Yeah.
And I can make this active here, and I can do untrim, and I can just pick the edges to untrim on this one here. So this way, when you do a roughing operation, your tool is not going to see those holes on the model.
Great.
So like you said, you know, you can take advantage of all your Rhino tools while you're working with the RhinoCAM plugin still active. So you're not leaving the Rhino environment in here. That's the beauty of RhinoCAM, is stay within Rhino, and you can continue using all your Rhino tools for creating CAD geometries. You can work along with it at the same time. So there is no nothing that would stop you from doing it.
This one might be tough. Let's see.
Okay, so let me go ahead and, yeah, we can patch that out over there.
Yeah.
So that's something we could do.
Or when I'm creating this, I'll save geometries before I do all of the Booleans.
Okay.
Knowing that I would be using them for machining later. Yep.
Right. So, you know, I may have untrimmed the layer in here, not the other one, right? You can see that. Yeah. I may have accidentally selected the wrong one. So let me go back and just undo all of these here. I'll hide one of the layers before I do it. So, okay, so now let me go ahead and just keep one of the copied layer active here, and we'll just go ahead and do the untrim command, run it real quick here in Rhino, and you can see that only one of the layers is active. So I'm not, you know, picking the holes from the other layer, the one that I copied. So basically, we're just doing a, you know, untrim operation, which you're familiar with in Rhino. And then maybe you can consider doing like a patch or something similar to that. And the only reason I'm doing an untrim is when I do a roughing or a finishing path, it flows evenly and it doesn't see the hole in the geometry for you. Yeah, and for this one here, we can try if the untrim will work. Looks like it doesn't seem to be. Okay, so that one is working, but not. Yeah, so let me go ahead and do a patch in here. And let's pick the curved points in here to see if the patch can handle that, take care of that for us. Okay, you can see there's some issue with the patch. So
Yeah,
what we could do
now
is we could do,
just leave it. Let the toolpath dive in for now. I get the point.
okay, okay. Or you could do surface using edge curves.
Yeah, I
Uh,
get that.
yeah, so you can pick these edges in here.
Yeah, exactly. Network surf, anything.
Yep, something similar to that. So yeah. So I'm just going to pick those edges.
Yep.
Okay. All right. So you can see the layer that's copied in here without holes is right there. So let's go ahead and build our workflow for machining in here. So step one is we want to go ahead and make sure that the machine tool definition is set correctly. So whether you're going to be doing 2 or 3 axis operation, you just click on machine and then you set the number of axes. So the standard configuration includes both 2 and 3 axis machining. So for applications for 2 and 3 axis, you leave it as 3. Experts, starting with expert, you have 4 axis capabilities. If you have a rotary table, either to turn the part constantly or index it, you can do expert. Pro includes starting with indexed 5 axis or machining with multiple setups. Pro includes all of those features. If you do not have a tool changer on the machine, or you can specify it to go to a specific tool change point, and this information can be relayed into the post. The next step is to selecting the post processor. This would be the CNC machine tool that you're going to be outputting the code for.
Can you see if you've got Laguna's IQ Pro?
Yep, we have several different posts for Laguna in here, and you'll find as you go through the list, the posts are either listed either by the name of the machine or the controller. So you can see there's one for the BR controller IQ. We also have several other Laguna posts in here, and I can bring them in as well. Okay.
Great.
So if you're using the BNR controller, it says Laguna BNR with the IQ. Then you can specify your file extension. Laguna likes .nc or .prg or whatever is the file extension they prefer. If it's .prg, you can just type in .prg. It'll accept it right there. Okay. The next step is to check the orientation of the stock and the part. So as you look at this part, you have 34.25, 34 and a quarter on the Y and 21 and a half on the X. So if the machine has more travel on the Y, as you're looking down at the part, then what you have is correct the orientation. If not, you may have to rotate the part around a little bit.
Yep, no, that's set up for my machine. It's a 2x3 in that way.
And then the next step I would do is, as you can see, I went through this process in here, build my stock. I can say box stock, and automatically when I click on copy model box, it computes a stock around. And you can see the part is free-formly up in space, so you can see the Z is about 7 inches above the part. That's okay. We can leave it in there, or we can move everything to the origin. So it's up to you how you want to do it. So I'm just going to leave it the way it is. And so right now the XYZ0 is still referencing up this point here in Rhino, which is the world coordinate system. So the machining coordinate system and the world coordinate system are coincident. But since the part is up above by so far above, you may not have so much of Z travel on the machine. So you probably would want to put the 0 to either one of the corners of the box and then top or bottom in the Z. So there's 2 ways to do it. One of the ways is you can actually do what is called align set world, and you can actually move the stock and the part to the origin, so it'll move to the origin. So it'll basically do a transformation in the CAD. The alternative option is to just insert what is called a work 0, and you can choose the location of your origin. So you could say you want to put it to the stock material, the southwest corner, which would be the lower left corner, and I can say the Z origin could be higher Z or lower Z, depending on where you want to put it. Okay.
Yeah.
Would you prefer doing the touch off at the top of the stock material, or would you prefer the bottom?
Like this, since I preserve some top always for when I touch off tools, I do top of the work. Yeah, highest Z.
I can do higher Z. And then the stock, what I've defined is the exact size of the part, but if you want the stock to be slightly larger, we can always go back and define that in here. So I can go back to the stock, box stock, and I can either change the dimension. I can make it 2436 in here. If you want to go with an exact size, I can change it to 24 by 36.
2436, because I want to see, I need some room for clamps, but I want the surfacing to not go past the actual part boundary.
So you notice that I created a 2436, and then I can do an align stock, and I can have it aligned so that the stock is centered around the part, and it leaves uniform material from all the sides. Now, once I've done that, all I have to do is double click on the work 0, just go back and re-update it to the corner of the stock. And you can see now the work 0 gets updated to the stock corner right in here.
Yeah, and do you have a way to set the zeros for a part like this? Sometimes I just go through the center of the part.
Yeah, so if you go to work 0, set to stock, high as Z, center.
Oh, center, perfect, because that way I can be sloppy on all sides. And
yeah, if you want to pick a specific corner or location, you can insert like a point, or you can snap to anything. You can say pick, and then I can just go pick this point right here, or I can say I want to put it right in here.
Awesome.
Yeah, so right now I put it to the corner, but if you want to do it to the center, just go back, edit, and then pick center.
Great.
Would you like me to leave it at the center right now?
Yeah, go for it.
Okay, all right. So you'll notice that now when you go to the setup, it shows the origin, where the origin in the CAD is, and then as you select work 0, it automatically translates the machining origin from the origin, WCS origin here, but the WCS still remains where it is. That doesn't move. Only the machining origin, or the machine tool coordinate system origin, is now changed.
Yep.
Okay, all right, so we are now ready to go to the next step in here. You can pick a material in here. So we have different material types. These are the standard that are included in the library, but you can always customize them. We have a XML file that is very easy to modify. So you can, it's an open source format, so you can basically edit to add new materials in here. So for example, if you consider this to be machining out of wood, you can select that, and then it'll also apply a texture for you for the simulation. It'll also help you in the computation of feeds and speeds. So if I go into one of these tools in here, and let's say I go to my feed speeds tab, I select load from file, it actually displays the computed feeds and speeds in here for the spindle RPM and the cut feed rate, and you can always go back and make changes to it as well.
And when you picked up the Laguna post processor, did it pick up the maximum spindle speed of that machine?
Yeah, so in this post processor, there's a section for spindle RPM. Currently it's set to 20 thou, and then the feed rate is set to 720, but you can always change that to what matches your machine. You can make it 28 or 30 or whatever that is with the max RPM. You can set it up here in the post. So you can always update that. All right, so we have some tools defined in here, and you said you wanted to add a 1-inch ball mill tool for it, right? To rough it out?
Yep.
Okay, so I'm gonna take one of these tools in here, and I'll just basically rename the tool to a 1-inch. And then I'll basically update the tool diameter in here. And then I'm going to do a save as new tool. Since it found the same tool with the same number, it just picked the next available number, but you can always go back and change this to tool number 1 or whatever the tool number that you like to use with it.
Yeah, this machine has a 3-tool changer, but I have to wire up the tool changer. So yeah, just getting everything
to 1. And then you can save the tool material to be carbide or high-speed steel. You can update this, go to feed speeds tab. You can go ahead and say, this is the feed rate. You can see it estimates it. If you change the spindle RPM, let's say you want to go at, 10,000 RPM for roughing, it'll recompute the cut feed rate. And then you can select OK. That gets updated. Save edit to tool. Your tool is now edited. Now I can go back and save this to my library, so it automatically has this information saved. So the next time you create your tool, you'll have it's going to be loading from the library. So you can hit Save Tool Library and then pick a folder where you want this to be saved. I'm going to call this Tools Inch. And it's all saving all of the 15 tools to my library.
Great.
Okay. All right. So we're ready to program some toolpaths in here. Now, since this part has, I would call it sculpted features, like the surfaces, they're not just planar faces. So you would need to do like a 3-axis operation in here to rough it out in levels or steps. You could do that. So we do that by going into 3-axis methods. Now with the standard configuration, we have 2.5, 3-axis, and hole machining. So in the 2.5, you get starting from 2.5 roughing, facing, pocketing, profiling, V-carving, engraving, all the way up to knife cutting, T-slotting, and knife cutting. The remachining is only offered in the Pro configuration of RhinoCAM. As far as the 3-axis goes, you have 5 different 3-axis methods, starting with the standard, which is horizontal roughing or roughing in levels or layers. You have parallel finishing, horizontal finishing or Z-level finishing or waterline finishing, and then you have radial and spiral machining. The rest of the methods that you see are offered in the Pro. Now the hole machining, you can drill, tap bore, and reverse bore with the standard configuration. Starting with the expert, you also have 4-axis methods, And so the 4 and 5 axis are 4 axis with the expert and 5 axis is in the premium, the simultaneous. Now this part, we wanted to rough it out, right? So first step is to go to 3 axis, we'll pick roughing. Now in this particular step, we want to rough it out, and if you do not pick any areas, the system will automatically analyze your stock, your part, and figure out the areas, and we'll go take a look at how that works. So I'll go ahead and grab the tool, the 1-inch ball mill. The feeds and speeds are set right here. They're automatically being pulled in from the tool. Your clearance is set to automatic, so it is a automatic goes a 1/4 inch above the stock, but if you want to change that, you can always change it in here. You can say go stock max plus a certain height. You can change the clearance height. You can do that. And then you can go into cutting parameters. You can specify your tolerances, your stock allowance, your cut patterns in here can be set. Your cut levels, how fine you want the cutter to step in levels. I could say I want to go down maybe an 1/8 inch per pass. I don't want to take more than 1/8 inch per cut. Engage in retracts, you can set it right here. And any advanced parameters like fitting arcs to your tool path and stuff like that. Arc fitting, arc smoothing. Now when you pick generate, the system is automatically going to analyze what you defined as your stock, the part areas, and it figures out where the material that needs to be cleared. Now, since I'm not picking or specifying any areas of containment, you can see that it knows the stock extent and basically clearing the material all the way around it. But we do not want it to go all the way around it because you want it to have some supports, you know, the stock being left around on the sides, right?
Yeah, I want like maybe because the 1-inch end mill, like half inch outside the.
So here's what I'm going to do is basically I can draw like a boundary in Rhino. So one of the things I'm going to do is basically just pick this endpoint and go all the way to the end. That's the extent of my stock. So I can pick this, and when I go to my roughing operation in here, I can select curve edge regions. I'll just pick this rectangle I created. So the tool path is basically, you know, contained into this area. So all of the material around it or outside of it is being not going to be cut into. So you can see that it automatically contained the tool path into this area. And for the outside, we can probably do like a profile pass to relieve the material, the excessive stock. We can do any of those methods in here. On the roughing, this is all we did here. And then if you want to go back and make changes, you can tighten up your tolerances in here. You can tighten up, you change your step over parameters. You can, you know, you have the control in here. You can say for the roughing, you want to do like a 30% step over. We have different cut patterns like facing. For cavity areas, we can do a pocket cut pattern. For core regions, you can do a facing cut pattern. You can choose the parameters. You can also go back and change your depth per cut in here. If you only want to take 100,000 per pass, you can do that, and then you just select generate. So the region is still being honored, so you can always go back and edit your operations and then generate the tool path.
And the kind of aqua lines versus the blue lines, what is that signifying?
Yeah, so the dark blue lines, what you're seeing here are arcs, true arcs being fitted to the toolpath. So instead of outputting them as a bunch of point-to-point moves, there could be some large arcs on your toolpath that are being created in here. So you can see the toolpath. This shows basically the toolpath in levels, and you can see there's arcs, true arcs being fitted to the toolpath. So that's your first cut level, and then it's going down to the next level. So instead of being outputting them as a bunch of point-to-point linear motion, it makes a nice smooth arc around the part. So makes it fewer lines of code and makes it much more efficient. So let's go to the simulate tab and we'll run a simulation in here. I'm going to hit the play button, and you can see it basically shows the simulation. So you can control the simulation speed as well. All you do is select it and then hit play, and you can change the simulation speed in here depending on how fast or slow you want it to run it.
Great.
And if you wanted to skip through it, you just do a pause and then select simulate it to end.
Do you mind me asking what kind of machine you're running on, just to get a sense for the speed? Like, I'm watching your progress bars. Are you on some crazy fast, like Xeon machine, or just a normal PC?
Normal PC. Let me go ahead and pull that up for you here. So if you can take a look here, it's just a i7, that's a normal box, nothing fancy.
Great, thanks.
Yep. Okay, so we just got through the roughing process in here. The next step we want to do is we want to go ahead and program a finishing cut, right? So you also have these flat sections on the part in here.
Yeah, I don't want to touch them because it's finished plywood.
Right. So one of the ways I would do is create some boundaries in here, or there's some gaps in here. So if you don't want the cutter to, like, you can actually go ahead and do what is called a 3-axis parallel finishing, and we
Mm-hmm.
can do surface selections in here, or boundary selections. I could say select surface boundary. I can pick surface in here, or I can just basically say part surface, select surfaces. I can just go pick these surfaces in here.
Oh, great.
And I can pick these surfaces in here, and I'll also just pick those patch surfaces as well.
Mm-hmm.
And these are the surfaces I would like to cut. So I have them all selected, and then I'm going to still use the same tool, or unless you want to go with a smaller tool.
No, that's
And
fine.
we can
For
go
now.
ahead and set the cutting parameters. This is parallel finishing, so it runs in parallel passes. If you set the angle of cut to 0, you would run parallel to x-axis, cutting back and forth. You can specify your step over control. I can say go 10% or 15% of the tool diameter. I could even do distance or scallop height, and you just basically pick generate. So in this process, it's going to create a finishing path for the surfaces that you selected in here. So in this case, I need to go back and retrim this here because it's finding some sort of a self-intersection on this face in here.
Right.
I can go back and repick it, but you kind of get an idea how it does it. Nice and
Can
smooth.
you, when you simulate it, does it give an estimate given the speeds and feeds of the time, the machine time?
Well, simulation is basically independent of the machine time estimation, but we do have an option called information. It'll tell you the machining time estimates.
Where is that?
I will show that to you here in just a moment.
Right.
So I'm just running through the simulation for the first operation. I'll run the simulation for the second operation. You can see it's doing a finishing pass.
Mm-hmm.
And you can also sort the sequence of cutting it. If you wanted to go from the origin away from it, you can do that. So you can see the finishing pass is just flowing parallel to x-axis, following the 3D geometry.
You bet.
So I can go do a pause, switch back here, right-click, information.
Mm. Oh, look at that.
Depending on the feeds and speeds, step overs, parameters that you put in.
And just, sorry, show me where that was again. You moved quick.
Right
on
click.
the setup, you went to show
Right-click
information. Okay.
on the setup, or right-click on the machining job, and then a right-click menu gives all of these choices, and here you pick information.
Great. Awesome.
Yep. I can even go back in here and make some changes. For example, I want to drop some of my selections in here. I could say remove active. So basically, I can highlight the ones I don't want to drop, or I can even hit delete. It'll remove those from being selected.
Great.
So you can see the boundaries were dropped from my selection right there.
Mm-hmm.
So I could go back in here, and I can also pick a combination of like curve boundaries too. I can say I want to pick these edge boundaries in here. So as opposed to selecting them as a surfaces, I can even pick surface edges. So I don't have to go and recreate any curves
as separate objects.
Mm-hmm.
That's
as long as they are chained or closed, it'll basically treat them as one closed boundary. I can also do a sorting, go from minimum distance, or I can do a directional sort, or I can do a minimum distance sort starting from the lower left corner. Now I pick generate. You will notice that the toolpaths are being regenerated for these areas in here, and I need to make sure I drop these in here as well. So you can generate the toolpaths. So depending on how you pick, so if this is open for some reason, it sees it as an open boundary. That's probably why it's skipping it. So one of the ways I could do it in Rhino is I can remove these all of the, okay, let me cancel this out here. Let me go to part regions, remove all of these. I can save it out. Now I'm going to go ahead and do what is called a duplicate edge. So you can take advantage of Rhino tools in here, and I can just go ahead and select these. And they don't have to be planar, the regions what you select, as long as they form a closed loop, you'll be fine.
And the problem might not be your boundary edge, is that surface has construction issues.
Okay, I can go back in here. I just made a copy of the operation, and I can just have this on a separate operation in here. But all of them, when you post, it'll be still one file. So I could go back in here and also apply some sorting rules right there. So we have broken up into two operations. And then there's the simulation. You can see since I put in some sorting rules, it's starting from the lower left and working its way up. And I can always change the simulation speed to go faster in here.
Great.
Do you have any questions so far?
This is great. I'm loving it.
Okay, so there's a lot more we could do in the simulations. I'm going to show that to you as well. We can apply different colors for each operation. We can either set them based on the tool, or we can define it based on the operation as well. So I can just right click and go to properties, and I can say, since I'm using the same tool, it makes more sense to use a color for each operation. So I'll pick one for the roughing. I'll pick a different color for the finishing in here. So once I set those colors, I'll go back and apply the same for this one too. I can change the color from the default to machining operation. So now the roughing operation is simulated in one color, the finishing has a different color, and you can see the cut material simulation, you can change the colors for it.
Nice.
Okay.
Till noon my time. So can we, there's two other things I'd love to get to before I have to run.
Sure.
So if you go now to the top, the first layer, the one that has all those holes.
Mm-hmm.
If I wanted to just do pocketing for all those holes, they're all at slightly different depths.
Okay.
Take me through that.
We'll do 2-axis. We could a couple of ways to do it. We can do either a hole pocketing or hole profiling or just a normal pocketing. So hole pocketing and hole profiling can do a helical interpolations. Now, depending on what size tool you plan on using for this larger one, so if you're going to be using a 1/2 inch tool, I would rather do like a hole profiling so it does a nice helical cut pattern. So I can do hole profiling. I can say select curve edge regions, and I can just go pick these either the curves, or I can pick. You can see I can select the curves from the model right there, right?
Can I trouble you? I was going to do both of these with just a 1/4 end mill, so I don't have to do a tool change, both the pockets and the through holes.
Okay, we can do that. So what I'm going to do here is use an operation called 2-axis hole pocketing, or I could just do a 2D pocketing in here. Okay.
Okay.
So what I'll do is I'll say select curve. And it looks like you already have some curves in the model in here.
Yeah, well, because I was using some really annoying software that.
Yeah. Okay. So we don't have to, I can lock these objects in, and I can just pick the curves real quick from the model, and you don't have to even, what we can do is one of the things I can do is basically select these curves in the bottom of the part. You can see that we have curves at the 2 levels, right? We have one at the bottom, we have one at the top, right? I'm just going to hide them, the ones at the bottom.
Yeah.
So we want to make our selection process a lot easier as possible, right? So you can do select by diameter or select by range. So in Rhino, you can even script certain things and you can do select by diameter. But here I'm just going to go ahead and say do a simple pocket operation. We'll just go pick. You can see because I locked the other objects, your selection is a lot easier. Just a click. It's not going to even bring out the selection menu. That's the beauty of working with an integrated CAD system, is you can take advantage of all your selection tools in here, right? So first step is I want to go ahead and take care of the larger pocket, or if you want to do the smaller one, we could do that as well. So I'm just going to go take care of the larger ones right now. I can even drag a window to select it. You can apply select by color, use different selection techniques that are available to you in Rhino. I have those selected right there. And then in the tool, I want to go with a 1/4 inch flat mill. I'll pick that from my library right there. I can change the tool number. I can update the tool feeds and speeds and properties. And then you got your feed speeds, your clearance. In the cutting parameters, you can specify it to not to leave any side stock. You have your cut patterns. In the cut levels, I'm going to say it's at the bottom. So even though there could be a different heights, different depths, I just pick at bottom. And if I don't specify any depth, the finish pass will be down at this floor. So it'll just go down in one pass to that level. You can specify your entry and exit. You can do arc fitting to your tool path, so which means it'll do circular passes. And then finally, I want to sort it, not jump around, and then do a generate. So we have a pocketing operation generated for all of these. Now, since I chose it's at the bottom, you notice that the tool paths are automatically honoring the depths based on the part. So you can see the depths are going to be different for each of the part.
Great.
So all I did was I chose at bottom. That's all I did here. Now I can go ahead and run a simulation for that. Now the next step I want to do is repeat the same for the 1/4 inch, right? So we could do a drill operation because you have a 1/4 inch tool. I could do whole machining drilling, and I'm going to say select drill points and circles, and I'm going to drag a window just to select all of these, and I'm going to apply a filter for the diameter and say pick holes that are of starting diameter is going to be 1/4 inch, and then anything larger than I would put in 0.5. So you can see it automatically excludes that. So only range 0.5, or I can even drop it to like 0.4. So I have these selected in here.
That's fantastic.
And then go grab a tool. We have the 1/2 inch flat mill, the same tool. Selected, feed speeds are set, clearance is set. In the cutting, I could specify where is the location of these geometries. Since the depth are varying, I could say I want to go drill it from the top down to the material. I could say pick top, and I can choose the top to be right over here. And then the depth to cut, I want to go from here all the way through the 3/4 of an inch. You can either do a standard drill, or if you want to peck, you could do deep drill, and you can specify your peck increments. I can say 1/4 inch per pass.
And is it going to go back, just back a 1/4 inch?
It'll, if you do a deep drill, it'll go back to the clearance plane, but if you do a break chip, it'll just go up to the previous cut level. That's like a chip break cycle.
So that's what I didn't have in the other software. Great.
And then you select the distance sorting type, generate. If I may ask, what was the other product you were evaluating?
It was Aspire.
Okay. And if you want to do the break chip before you do the pocket, you just reorder it, drag and drop, and now you can run a simulation. You'll notice that if I go back and slow down the simulation, you can actually see the peck cycle taking place in here. So let me go ahead and slow it down further a little bit. So I'm going to go ahead and hit the play button. You can see it shows the peck cycle.
Yeah, great.
Yep. And let's do a pause, pick to end. So we got through the break chip cycle, and then finally we want to do the pocket.
And a quick question. So far, have we done any operation that's not in the standard RhinoCAM level?
No, we have not.
Okay, great.
Everything that you see we programmed is all in the standard.
And if I then got to a point where I wanted to move up a level or two, do you have that kind of upgrade?
Yes, we do have an upgrade path available going from one configuration to the next.
Right.
Okay, so I'm going to hit save here, or I can do a save as. I could do file, or I could even say save as. I'm just going to call this revision 1. So this automatically will save the CAM data into the CAD file. And then I'm going to select right click and information. That gives us the estimated time for cutting it. I'm also going to generate before I do a post, I'll do what is called a shop documentation. This actually will get you a nice little setup information sheet. It'll have information about your tool, your feed speeds, all of it that you need. So if you want to send it out to the operator in the shop floor to run this part for you, and you're not sure, he's not aware of what the operation is going to be doing, what tools he needs. So this is a very nice setup information sheet. So he can be well prepared what to expect on this part. And this can be automatically previewed in your HTML viewer.
Look at you. Nice.
And it shows the work 0 location. Whatever display you display in Rhino gets automatically screen captured.
I love it. Two quick final questions. Can you just try and, with tabs, do kind of cutting out those 6 kind of slats? So
absolutely. So let me go back in here. I'm going to go ahead and unlock those objects. So I want to do what's called a profile cut. So I'll check the gap between the two, analyze distance, make sure I can fit a tool in here.
It should be exactly
1/4 inch. Yeah, okay. So we have different ways to do tabs and bridges. I'll do a 2-axis profiling.
Yeah.
And just to make it faster in here, I can say select curve edge regions, or I can even extract curves. I can just go pick these regions. I'll just pick a pair in here, so that way you get the idea how we're doing it, right? So I'm picking these pairs. So, and then I have them selected. I still have the same quarter-inch tool, feeds and speeds, everything is set. In the cutting parameters, I'll choose I want to climb cut. I want to go outside or inside, or I can say determine the side to cut based off the 3D model. And then you can specify your feed speeds, your cut levels. It's at the bottom, the geometry, what you've selected. Or you can say pick top, and you can say you want to start the cuts, begin the cuts from here. And you can say how deep you want to cut. You can measure the depth from the model. You can just click this here and then say pick to 2 points. So the 3/4 inch, we can say we want to break it up into quarter-inch steps. You can specify your entry and exit, or you can just do like a plunge cut, and then specify any parameters for arc fitting. The cornering, by default, it's going to go like a rollover round, or you can say sharp corners. And over here in the advanced cut parameters, this is where you specify the type of tabs you want to insert, rectangular or triangular. Give it a height in here. So I'm going to say the height will be 150 thousandths. The length, maybe I'll make it a 1/2 inch long, and how many bridges and tabs, I'll put in 4, and then I will generate.
Is that 4 total? Well, I'll find out in a second.
Okay, I'm sorry?
I wondered if it was 4 total or 4 per slab.
4 per part, per geometry. Yeah. So it'll be 4 per part. Okay, you'll notice that it creates 4 tabs, and those tabs are automatically generated. They're not at any specific or particular areas. So if you want to control, there's a way to do that as well. I'll show it to you real quick. So right now these tabs are automatically being inserted. I'll do a pause and go simulate to end. And you'll notice the location of the tabs. So in this case, since you have the parts that are so close, the point of having the tabs in here is not going to have any effect because it's being chopped off with the other operation.
So it's actually sending the tool, in this case, twice through that middle point.
Yes, that is correct.
And so what I ended up doing, I mean, I would draw this differently, is I selected all the odd slats, and then I just did the sides of the other 2 just to save on machining time.
You could do that. Now, one of the other ways I would do probably is for the bridges and tabs, is being able to pick bridge point locations exactly where I wanted them to be placed. So I can go into this tab called regions, and I can select curve regions, and I can, like you wanted to do it here, I can just pick these 3, and I can pick these 3 in here. Right click, that'll create 2 curve regions in here. You see that, sir? And now I can go ahead and pick bridge point locations where I want my bridge points to be placed. We have what's called manual bridge points, and I can select locations. I can say one of my bridge points to be in the midpoint of this line, over here, over here. I can do the same. I can select this one here, pick bridge point locations, manual bridge points, place one right here, one over here, one over here. If I want to move a bridge point, I can just select this here, and I can click on edit bridge points in selection, and I can basically drag and drop it.
Right.
So you have the ability to drag and drop your bridge points. You can insert bridge points. You can also add a bridge point in here. So manual bridge points, I can go back and insert one. Now, once I have done this in here, I just go back to this operation, profiling, double click on it, and then instead of picking those curves from the model, I can use these predefined selections in here. And I can apply, for the cutting direction, I could say determine the side of cut using the 3D model and generate the toolpath. So it's erroring out on the model here, so I'm just going to go back and choose cut right or cut left.
Outside, yeah.
Yeah, I'll just pick, because I picked an open chain, the cut right or left is probably going to go, I need to use cut right or left because it's an open, it's not closed. So I'll pick cut left, and you'll notice that the cuts go on the direction that you want. And now when I run a simulation, you'll have the bridges exactly where you pick them, the bridge points.
That's great.
One of these 2. So the final thing we want to do is post-processing in here. I wanted to show you the posted code. So you right-click on the setup and do a post. It's going to post all of your operations. The name of the file is automatically used. The name of the setup post will get you the G-code output. It automatically displays in a text editor. It could be Notepad, or you could use your own editor of your choice to preview the code. It calls out your tool number, D1, the offset, and then you have a tool change. I'll do a search for the next tool, T2 right there.
And it went to T2 because you named that tool T2. I could have named that T1.
Absolutely.
What I would have just saved it as 3 different files. Can I save them as 3 different files?
Absolutely. One of the things I would like to do is like take these 3 operations, right click and do a post. You can selectively post them, how you select files for moving, or you can even group them into what is called a machining operation set. Now these 2 options, mop set and machine control, are included in the standard. So you can select a mop set. I can select these 3 operations, group them in here. You can call this based on tool number. You can group them in here. And these 3 operations are using the same tool. I can add another mop set folder in here, and I can pick maybe this and this, just drag and drop them into it.
Great.
And now I can post the first set. Yep.
1-inch end mill.
Yeah.
Right.
Yeah. You can call it EM ball mill, and then I can call this EM for end mill.
Great. That's great.
And then you can post the mop sets out to your machine tool.
Very helpful. Thank you for your time. I'm this summer going to be upgrading all my machines, and probably moving up to RhinoCAM because this is just a much better workflow.
Okay, great. Let me go ahead and hit stop to stop the recording here.